Hey, fellow stargazers and cosmic explorers. Have you ever looked up at the Milky Way and wondered, where exactly are we in all of that? For millennia, humanity grappled with this profound question. Join us on an epic journey through time and space as we uncover the incredible scientific detective work that finally revealed our true home in the galaxy. For most of human history, it felt utterly obvious that Earth sat at the universe's heart. The sun dutifully rose and set for us, and the stars wheeled overhead in a nightly celestial ballet. From our everyday perspective, this geocentric view was the most logical conclusion. This deeply ingrained belief wasn't born from arrogance, but from our very human instinct. Our perception naturally places the observer at the center of every story. Just as each of us experiences life from our unique viewpoint, entire civilizations built a cosmic worldview with Earth as the undeniable focal point. Yet, science has a remarkable way of gently, and sometimes painfully, pulling us away from comforting assumptions. The revolutionary realization that Earth orbits the Sun was the first seismic shock. Then came the humbling truth that our Sun is merely one star among billions, a speck in a vast cosmic ocean. Eventually, an even deeper, more existential question emerged: where exactly are we situated within our own magnificent galaxy? This wasn't just an astronomical puzzle, it was a philosophical reckoning. To pinpoint Earth's location in the Milky Way was to confront a humbling truth. True significance doesn't stem from being central, but from the profound act of understanding. Long before the invention of telescopes or complex equations, the night sky itself offered a tantalizing hint. On dark, moonless nights, a faint, luminous band stretches majestically across the heavens. Ancient cultures saw it as a celestial river, a divine road, or even spilled milk from the gods. Today, we know it as our home galaxy, the Milky Way. This ethereal, glowing band revealed something profoundly important about our cosmic neighborhood. If stars were uniformly scattered in all directions, the entire sky would glow with an even, diffuse light. Instead, they cluster intensely into this narrow, brilliant strip. This striking observation strongly suggested that our galaxy isn't a sphere, but rather a flattened disk, and crucially, that we are embedded somewhere within its plane. The Milky Way appears to divide the sky because we are looking along its vast, pancake-like plane, not at it from a detached vantage point above or below. And therein lay the monumental challenge. To truly grasp the galaxy's three-dimensional shape, we would need to travel thousands upon thousands of light-years perpendicular to this plane, a feat far beyond our capabilities. Consider this: Voyager 1, the farthest human-made object, has journeyed for nearly half a century and has only covered about 0.02 light-years. Leaving the Milky Way for a better, external view was, and still is, an impossible dream. If we couldn't step outside our cosmic home, we would have to map it from within, a monumental task demanding ingenuity, logic, unwavering patience, and boundless imagination. In the late 18th century, a visionary astronomer named William Herschel dared to attempt what seemed utterly impossible. Armed with powerful telescopes he meticulously built himself, Herschel embarked on an ambitious quest to chart the intricate structure of the Milky Way. He didn't have cameras. Instead, he painstakingly counted stars. Together with his brilliant sister Caroline, Herschel systematically divided the entire night sky into roughly 600 distinct regions. In each of these sections, he carefully recorded the number and perceived brightness of every visible star. It was a monumental undertaking, demanding relentless discipline and an unwavering faith that meaningful patterns would eventually emerge from sheer numerical data. Herschel's approach was nothing short of revolutionary for its time. He treated the galaxy not as a subject of mythology or an impenetrable mystery, but as a quantifiable system that could be measured and understood. From his meticulous data, he concluded that the Milky Way was indeed disk-shaped, and, based on his star counts, he placed our Sun near its very center. Though his conclusion about our precise position would later prove incorrect, his pioneering method was absolutely groundbreaking. For the very first time, humanity attempted to draw a scientific map of its galactic home, armed only with diligent observation and rigorous reason. Herschel demonstrated that even within the vast, seemingly chaotic darkness, underlying structure could be found, if one was patient and persistent enough to truly look. Herschel's error wasn't due to carelessness, it was caused by something entirely invisible to him: interstellar dust. These microscopic particles, composed of silicates, carbon, and ice, drift ubiquitously throughout the Milky Way. They absorb and scatter starlight, particularly light traveling from the galactic center. As a result, vast regions teeming with stars appear dim or even empty through Herschel's telescopes. The galaxy's true core, a bustling hub of stars, seemed deceptively sparse, leading him to mistakenly place the Sun near what he perceived as the center. In reality, the true center was simply hidden from his view, shrouded by cosmic haze. This historical mistake carries a powerful and enduring lesson for all of science. Progress doesn't happen by being right at all costs, it advances by recognizing our blind spots and correcting past errors. Each generation of scientists sees farther not because they are inherently wiser, but because they stand on the shoulders of those who came before, building upon and refining corrected assumptions. In our own lives, we often draw conclusions from incomplete information, just like Herschel. We map our personal realities through the haze of what we cannot yet fully see or understand. True progress, both scientific and personal, begins the moment we humbly accept that our current view may be obscured, and that a deeper truth may lie just beyond our present perception. At the dawn of the 20th century, Henrietta Swan Leavitt worked quietly and diligently at the Harvard College Observatory. Her assigned task was to catalog variable stars, a meticulous job few considered glamorous or groundbreaking. Yet, within this routine work, Leavitt made one of the most profoundly important discoveries in the history of astronomy. She noticed that a specific class of stars, known as Cepheid variables, followed a remarkably simple and consistent rule: the brighter the star's intrinsic luminosity, the longer its pulsation period. This elegant relationship, now famously known as Leavitt's law or the period luminosity relationship, transformed Cepheids into invaluable standard candles for the cosmos. By precisely measuring how fast a Cepheid pulsed, astronomers could accurately determine its true intrinsic brightness. Comparing this to how bright it appeared from Earth allowed them to calculate its exact distance. For the very first time, humanity possessed a reliable, universal ruler to measure the vast distances across space. Leavitt did not seek fame, nor did she live to witness the full, revolutionary impact of her discovery. Yet, her meticulous work transformed astronomy from educated guesswork into precise, quantitative measurement. She gifted humanity the unprecedented ability to reach across unimaginable cosmic distances, not physically, but with the elegant power of mathematics and observation. Before the 1920s, the prevailing scientific consensus was that the Milky Way constituted the entire universe. Faint, fuzzy smudges like the Andromeda Nebula were widely believed to be mere clouds of gas and dust residing within our own galaxy. Then, Edwin Hubble, a brilliant and determined astronomer, changed everything forever. Using the powerful 100-inch Hooker telescope at Mount Wilson Observatory, Hubble meticulously searched for and identified Cepheid variables within the Andromeda Nebula. Applying Leavitt's groundbreaking method, he then measured their distances. The result was absolutely astonishing. Andromeda lay far, far beyond the previously imagined boundaries of the Milky Way. The universe, in an instant, expanded to an unimaginable scale. Galaxies were not rare anomalies, they were everywhere, countless island universes scattered across an infinite cosmic ocean. The Milky Way, our cherished home, was revealed to be just one among billions. This revelation was deeply unsettling, yet profoundly exhilarating. Humanity lost its perceived cosmic centrality, but in return, gained something infinitely greater, a universe far richer, more mysterious, and more awe-inspiring than anyone had ever dared to imagine. It was a paradigm shift that redefined our place in the cosmos. If Edwin Hubble demonstrated that the Milky Way was not the entire universe, then Harlow Shapley delivered the definitive proof that we weren't even central within it. Shapley focused his research on globular clusters, ancient, tightly packed spherical groups of hundreds of thousands of stars that orbit the galaxy in its halo. Shapley meticulously mapped the distribution of these globular clusters and noticed a striking pattern. They clustered heavily in one particular direction of the sky, specifically towards the constellations Sagittarius and Scorpius. This could only mean one thing: the true galactic center, the gravitational heart of the Milky Way, lay in that direction, far, far away from our sun's position. Our solar system, it turned out, was displaced to the quiet, outer outskirts of the galaxy. It was the final, decisive dismantling of an illusion that had persisted for thousands of years. Yet, instead of diminishing humanity, this discovery refined our understanding and expanded our perspective. We learned that true importance doesn't come from a privileged location, but from the profound insight gained through scientific inquiry. Today, thanks to centuries of dedicated scientific effort, we know our precise cosmic address. Earth resides in a relatively small spiral arm known as the Orion Spur, nestled approximately 26,000 light-years from the bustling, supermassive black hole at the Milky Way's center. We are neither too close to the chaotic, radiation-filled core, nor adrift at the desolate, metal-poor edges of the galaxy. It is a remarkably balanced and fortunate position. Too close to the galactic center, and intense radiation, frequent supernova explosions, and gravitational turmoil from the supermassive black hole could threaten the very existence of life. Too far out, and the heavy elements necessary for the formation of rocky planets and complex life might be scarce. Our location appears, quietly, improbably, and wonderfully, just right. Perhaps this isn't mere coincidence, but rather a profound cosmic context. The universe didn't place us at its physical center, but it placed us in a Goldilocks zone within our galaxy where observation, reflection, and the flourishing of complex life could thrive. It's a testament to the subtle, yet powerful, conditions that allow for our existence. In 2013, the European Space Agency launched a revolutionary mission named Gaia. This incredible spacecraft was designed to achieve what William Herschel could only dream of, to map the Milky Way in exquisite three-dimensional detail. Gaia has meticulously measured the precise positions, distances, and motions of over 1 billion stars, creating the most detailed and accurate portrait of our galaxy ever conceived. It is, in many ways, the ultimate Google Maps for the Milky Way, providing an unprecedented understanding of its structure and dynamics. For the first time in human history, we can truly see our galactic home not as an impenetrable mystery, but as a living, breathing, evolving system, rotating, interacting, and changing through cosmic time. We now know exactly where we are. And this profound knowledge doesn't make us feel smaller or insignificant. On the contrary, it makes us infinitely wiser, more connected, and more awestruck by the sheer grandeur of the cosmos. Isn't it incredible to think about the journey humanity has taken to understand our place in the universe? From believing we were the center of everything to pinpointing our exact address in a vast galaxy, it's a testament to human curiosity and scientific endeavor. If you're as fascinated by these cosmic revelations as we are, hit that like button and subscribe to our channel for more deep dives into the wonders of astronomy. What's your favorite part of this galactic detective story? Let us know in the comments below. We love hearing from our fellow astronomy buffs. And don't forget to ring the notification bell so you never miss our next cosmic adventure.